Hey, welcome in. I'll just give it another 1 minute and then we'll get started. Just let people join in. We'll be going over the detecting shorts, basically. Dead shorts, low ohm shorts, all the kind of, well, it's not that many shorts, but we'll basically be going over that. There's quite a bit to cover, surprisingly. Just on, you'd think a short is fairly simple. You know, like you just get a short and you can find it, but there's actually quite a few ways of getting a short and ways to detect them and things. Oh, nice. Managed to fix your clean screen PCB. What was the faulty part? Hey, welcome in. All right, I think we'll get started now. Anyway, we've been live for 5 minutes. I think that's enough for most people to join in for now. So what we're covering, yeah, the latch. Yeah, so this, like one of these latches. Yeah, to be honest, they're quite easy to break if you're not used to them, especially the long one. If this gets a bit of flux or stiff, you can quite easily snap them. What we're covering in this one is going to be finding, obviously, as the title kind of says, but finding and detecting shorts on boards. So I've got a few examples here. These, like, obviously, making a short or finding a board with a short can be quite difficult. We had one with a funny plain screen the other day where it was shorting out down here. But luckily, I can fake the shorts very easily so that you guys can see the issues. What I'll probably do is put a short on the board, not show you where it is, and then show you how you can find and detect them. There's a few things we want to cover. The first is ways to detect shorts. So I'm going to have to probably, I'm trying to think which way around. I'm probably going to have to make a semi-common short on this board. So if I, yeah, I'm going to have to pull up the pin out on this a minute. I'm going to do a short on this board that acts like probably one of almost the most common shorts, which is when a component actually fails and it's not a dead short. So let me just start by effectively making a short on this board. I just need to check something a minute on the schematic, and then we'll get going. I should know this off the top of my head by now. I've worked on the Game Gears that much, but I still forget the pin out sometimes of things. Right, yeah, okay. What I'll do is put this camera up. I'm going to move your guys' focus. Of course, I've forgot to turn this USB stick off and shorted. 1 second. I didn't turn off my little tool for moving the camera last night. I'm going to move that up there, zoom in, and you can just stare at that for now. You won't be able to see what I'm doing. And then we'll go through detecting and finding the short in a moment. And you can imagine this is going to be, a natural failure, not something I'm purposely inducing on the board. And then we'll go through some mechanisms. So I reckon, yeah, this will do the trick. Try not to reveal what I'm doing too much, but you'll see when we come to find it and go through all the methods you can use. And we can play Sherlock Holmes on what I'm doing on this board. Right, and that's the sneaky plan done. So you guys can now actually see what I'm doing. So we have a board here now that has, because I've just done it, we have a known fault on this board, which is a short. And we want to detect shorts. So there's various kinds of shorts. We'll cover the exact ones in a minute, but a few that you should know of is when things short out, say capacitors like these start to fail, what happens is they get a lower resistance than, well, basically capacitors should have no resistance when it's DC measurement. When capacitors start to fail and internally short, they start getting a lower and lower resistance. So like a kilo ohm, then 100 ohms, then 50 ohms. These are just known as shorts. So these are normal shorts, like component failure shorts. If they fully fail, or sometimes bridge, or there's other issues, it's called a dead short. So a dead short is basically an almost 0 ohm resistance short. So they're the two major kinds of shorts. You can call one a dead short, which some people, like especially me as well, I'll probably say the same thing. I might just say, oh, there's a dead short on the board, and it's not a dead short. It's actually a 50 ohm short. But take it with a pinch of salt when people say a dead short or a short. They are technically two different things. But what I've put on this board is actually a regular fault. So this is what might happen if these caps are bad. And to be honest, the caps might be bad anyway. So the simplest way of detecting the short is if you only have a multimeter. So if that's the only tool you've got, that's what we're going to try and use here. What's the resistor value on the Game Boy Color Clean Juice clear board next to the blue LED? Clean Juice clear board, as in that the LED that lights up the blue LED. It's probably 470 ohm, but you probably want to put it about 2K. 2K is more of a realistic value to make it dimmer if that's what you're trying to do. Look, my mouse can go in this window. Let's see if I haven't turned this on in a while. Let's see if this actually connects. Has the IP address changed of my multimeter? Oh. I think the IP address has changed of my multimeter. And I haven't bothered writing the software to detect it. Probably can't be bothered to find it. Right, it's definitely got LAN. Okay, let me turn the meter on and off. I mean, we don't really need this meter, like, you know, to show you. I just wanted to show you with me nice fancy software on stream. It should actually tell me the IP address when it boots as well, I think, so I can actually just get it off the multimeter thinking about it. LAN connected, configured. Right, let me see if I can connect to it then. Connecting. It's strange because you'd think the IP address wouldn't change. Where's the menu on this thing? I never use this multimeter. Menu. I'll tell you what, I might even have the proper software installed at the minute anyway, the Ultra Sigma, I think it's called. Let me just see if this detects the multimeter a bit quicker, and then I'll figure out a way to hopefully automatically detect or just static IP the multimeter. Because this shouldn't have changed. Ultra Sigma. And it doesn't look like it's finding it. How weird. Auto detect search. There we go. Yeah, it's changed its IP and gone to 119 instead of 118. That's bizarre. There we go. Right, so multimeter in. I'm going to change it to ohms, and then we should get 0 ohms. So the first way to try and detect a fault on this is, say we power this up now. Well, let me show you actually what happens when you power it up. Let's get a Clean Juice board off Zach's desk. And the thing with the Clean Juice is it's quite a powerful device, so it's probably going to handle the short no problem. And we might not see anything that obvious, but if I plug a power board in, into here, and we're going to attempt to boot. This is obviously, it's got no chips on, so it's not going to boot anyway. But yeah, this is all coming on. All the lights are coming on fine. And it appears to have no issue. So what would normally happen on here, and this is because the Clean Juice can handle it, is if this was a working Game Gear, you might get like red light boot not coming on. You might get smoke coming from somewhere. You might get, normally your power supplies won't work and they'll, like, your power lights will fail. Because the Clean Juice is a beast, it's just managing that short, no problem. But let's presume that failed and we had a hint that there's maybe a problem and a short. The first thing I'd do on a short is, again, if you don't have any other equipment, then you would get multimeters in resistance mode, and we're going to probe, say, the 5-volt rail. So again, we can go on ground, say up here, and the 5-volt is the positive down here on the input pin. And you can see there we've got a 95 ohm resistance. So that's might be normal on some systems, but that's quite low of a value to have on a power rail of an unpowered circuit. 300-400 ohms is normal for some circuits. Rarely is like, 100 ohms. That is not normal for a circuit. Because if this is getting 5 volts, what you do is take 5, divide it by 95 ohms, and that will get you the current that this is going to pull. So that's quite a bit of current to sit on a board that isn't, shouldn't have a fault. So your first hint that there's a problem is your multimeter. That's one way of detecting shorts, is through a multimeter. I'm looking at one of them books. To be honest, China's quite quick. AliExpress for resistor books is fairly quick. You're unlikely to get them anywhere else. Not many people. I used to sell them and stock them, but I don't anymore. So that's probably your best bet, to be honest. Yep, this is for detecting shorts. So we've used a multimeter. That's method 1 of detecting a short. And now we have another method. So another method is looking for heat with IPA. So what you can do is you can either power the unit through a Clean Juice or anything else, power your system and turn it on. And then while it's on, you can spray with IPA to look for heat. But to kill 2 birds with 1 stone, the other method is also to use a bench power supply. So if I get a bench power supply here, and this is going to allow me to now power the console and see the current draw and see if it's expected. So to do that, we're going to hook up a few wires. Let's grab 2 wires. They're both red, but it doesn't matter for my purpose. Change the soldering iron tip. And I'm going to tack on ground and power. Where are we? So we have these 3 are ground, I believe. So we'll tack a ground on here. And then 5 volts is down here, so these 2 are 5 volts. So I'm going to tack a 5 volts there. So now I'm just going to power this board up through bench. So ground can be ground, which is normal. 5 volts can be 5 volts. And to show you the actual current draw, I should be able to bring up the meter, go to current, put the probe in the right connector place, like so. Get these leads, and I covered this when we went over multimeters, but now instead of injecting 5 volts straight to the board, I'm going to pass 5 volts through the red, so this is going through the meter. And now when I touch on the 5 volts on the board, so say here, you can see there we get 150 milliamps. So that would be fairly normal. But bear in mind, this has no ASIC and no RAM, and I know I've caused a short. So a board with nothing on, like no ASIC, no RAM chip, just powered up, there's really only video RAM that draws about 10 milliamps. So this entire board, because there's nothing on it, should be about 10 milliamps. So it's important to understand when you're measuring for current like this and you're probing on and you're getting X amount of current. So in focus. There we go. It's important to know what is normal. So on another Game Gear with all the stuff on it, this would be completely normal. 140 milliamps would be a normal Game Gear. But this is a Game Gear where it's got nothing on. So it's not necessarily just about current. If I were to just short the board out straight to ground, so if I just went straight to ground and shorted out completely, you can see we've got 3 amps current draw, just completely shorted out the bench. So that would be, if we had a dead short, you'd be seeing like, 3 amps, it just max out your power supply. But because this is obviously a known short I've caused, when we touch on here, we're getting this unexpected current. So second method to measure or to test for shorts is a bench. This is one of the best ways because you can see the actual current draw. And the other way is, say, IPA. So we have the third method of IPA. If I've got a gripper, 1 minute, where can I nick the gripper off? I'm just going to grip this onto the tester so I don't have to hold it. This should be strong enough. And now we've got that permanently attached, and I can free move this. So method 1, resistance. Method 2, bench power to see the current. Method 3 is IPA. So these are all in order of, well, not necessarily in order of cheapness. It would be a multimeter for resistance, then IPA, then your bench power is probably the next most expensive way to test, and we have one other fairly obvious way to test after. So if I was to look for a short on this with IPA, you'd spray around the board and you'd look for IPA evaporating fast. The problem with this method is 100, so you can see it's actually gone up in current now, but that's more than likely an actual fault on this board somewhere, because that shouldn't have added current. So we do actually now have a real short as well, not just the one I've made. But spraying IPA on, you can see even 0.5 amp, you're not really going to get evaporation that obvious. It's going to be very hard to spot where a short is. Now, I'm going to show you where the short is, so we know. And then we can look at seeing if the methods work when you know directly where to look. So the short I've done is a fairly simple short here. And this could happen to you by mistake or real. So all I've done is put a literal 95 ohm resistor over the power pins here. This could have flown off for you, but what this is simulating is a capacitor actually slowly dying. It would simulate very similar behavior. And that's what we're trying to detect. So you can see, even now, if we know the short is here, let's put IPA on. And you can see you can't even tell. The IPA isn't really evaporating on that resistor. So even though we have a short, and this would be enough to cause an issue, you can't even, like IPA can't detect it. The current will tell us there's a short, but not where. And the resistance tells us the resistance. So at this point, we have 3 methods to detect a short, and not one of them can actually detect this short. So there is a 4th method, which is the most obvious that everybody will know, and that is to use a thermal camera. So this is the method you'd use for most short detection. So what I'm going to do is see if I can get this thing on screen. If not, I can kind of do this, which is not that bad. But I think I can overlay this on screen so you guys can see what I'm seeing. This board is just a board we're using to test and show people where and how to find shorts. It's not a real problem. It's one we're simulating to show how to find shorts, basically. So now we have the thermal camera up. You can see it's on. Let's quickly see if it's even going to detect that resistor should be getting toasty. Yeah, so straight away, there we go. So that's detecting that and again, notice it's only 28 degrees. It's not super hot, but it stands out that it's not right against the board, basically. So it's a very clear hint that there's a problem, even though the rest of the board is fairly normal temperature. So this method works. Let me just see if I can overlay this on this view. I haven't set it up permanent yet, but I think all I need to do is do a video source, and I think it appears as a webcam when I plug this in. So let me try and add source, add a new source, we'll put thermal, and then I will get this overlaid on stream permanent in future. But is it UVC cam? Yes, there we go. So UVC cam. Let me move this into some kind of position. So probably just down the bottom corner for... oh, actually, I just noticed on the vertical layout, we actually have a bit of black at the bottom on that camera. There we go. Missing out a little bit of the video. And then on this view, we will move this to bottom corner here, I reckon. Right, there we go. So now we have this, what's on the screen, I can now use without having to try and keep it on screen. And we can see then, if I look for the short, there we go. I am now pointing at, obviously, the resistor here. So this method works good. You can see as well, there's different levels of thermal. So that isn't the best. What you'd now try to do is go, right, where's the short? And the best way I do is to get a pair of tweezers, soak them in IPA so that they appear cold on the thermal camera, or at least visible. So you can see on this, if I'm wafting the tweezers in front, you can just about see they're there. So you can see that tip. And then what I do is aim at the hotspot, move my tweezers in, and let's try and get this a bit more. There you go, that's a better layout. So you can see now what I'm going to do is try and move the tweezers and cover that spot. And then when you finally cover it with tweezers, you see it disappear. So you can see I'm kind of hovering over and covering that hot spot. And then you try to get it where you're actually touching the heat. So like there, say, it looks like I'm touching, but there also does as well. So you can see then when you're looking at this, I'm touching between here and here, like somewhere here with the tweezers. It's not the best accuracy due to the limits of this thermal camera. But quite a lot of thermal cameras will be this level of resolution. You kind of can't see what's going on, in a sense. You can't see for sure. So the better method for that is a better thermal camera. So all I would do, or if I've got a short, I have obviously a lot of thermal cameras. So what I'd do instead of that is we turn all them overlays off. I've got this one. I've got many, but this one's a really good one for resolution. So I'll bring this in, and then we will move this over, and I'll show you here the difference between the other. Oh, geez, I've still got the still got the 400 volts. There you go. If you want to see what happens with 400 volts, I'll show you the melted finger. This, even though it's got nothing on, we've still got the inductor there. We've still got the high mains voltage. That was like 1,000 volt shock then. Totally forgot about that. I'm that used to working on game gears without that. That stinks. I've literally burnt my finger. So with a high quality thermal camera, if we get the focus distance right, then look at that. There's the difference in quality of trying to find where the problem is. So we bring the focus distance just right for this camera, and you can literally see exactly where the fault is. So get that in view. And now with that, I can move my tweezers in, and I can literally see my tweezers. I can see the shape of the tweezers. I can go directly over the blob. So say there's the heat. I can move away, and if I keep that there and zoom down, well, I can change camera. We go to the overhead. You can see where I've ended up putting my tweezers, literally right on the problem. So thermals are definitely the way to go for most shorts. Like that is the probably one of the best ways to find a short is through thermal. Really, that's most methods of finding shorts is resistance for one, IPA for another, bench powers to see the current draw for another, and thermals for a fourth detection method. Now, the benefit with the bench power is you can probe around and inject voltage into certain rails. So what I'd normally do is get 1 volt and inject it into each rail and find where the short is. Now, there are some things to look out for. There's also different kinds of shorts, but let's first just cover one thing to look out for. So this might not happen on here, but if I now change the short, and if I turn the power off a minute so I don't zap myself again, I'm going to change this to a dead short. So this is currently just a normal short. So it's a low ohm short. What I'm going to do instead is simulate a component, maybe like a transformer. that's shorted out between the two sides of the circuit and maybe shorted ground to power or something like that. And this does happen fairly often. So for that, we'd end up with a literal dead short. So there's a 0 ohm short on this now. This could also be if you've soldered chips down and accidentally bridged something. So say you were soldering this chip and you'd accidentally bridged 2 pins, you were swapping caps and you bridged 2 pins. A dead short is very easy to mistakenly do when you're soldering. The problem with this now is this is very difficult to detect, as you'll see. And there's a lot of ways that this can also throw you off, and I see it all the time. So now if we overlay the current, I connect the current back up to the bench, and you can see there, we now get 800 milliamps. We should really be getting 3 amps, but something else is limiting that current, and I know exactly what. If you've got current that's that high as well, don't tend to just keep your bench power powered. You don't want to burn things out. But let me show you exactly. I know what's going to happen here. Firstly, if we look at the board where we know the short is, and we point it there, you can see stone cold. There's absolutely no heat there whatsoever. We've now got 3 amps, but the problem is, if I look quickly to show you, because it's already burnt out and blown, we go down here, you can see smoke. So there's a sign of where the problem is. Look at that smoke and flame. So this thing is clearly burning out and blowing out. And on your thermals, you can see this thing will be hundreds of degrees. So this is upside down, but 160 plus degrees. So you might go, there's a short. Oh, it's this inductor. And you need to understand what things are as well. So the first red herring in finding shorts is that you might go, this component's faulty. So I'm now going to replace this component. Now, the only reason this is getting hot is this is on a Game Gear. This is the 5-volt rail. Then this inductor is acting as a filter for the audio channels. So this filters noise from the audio. They've put it in a bad position. It should be literally right here. And it's not designed right or with spec. And then it also goes through a very thin trace all the way around the edge of the board. So this is a really bad PCB design by Sega. But the point is, the inductor's there to filter noise. And this is, again, common on circuits. So you might get that this inductor is warming up. And you've seen it's probably still warm now. You know, still cooling off now. But you'd probably go, that's the fault. There's literally a component getting warm. What you have to understand is that there's parts of a circuit that power can pass through, that if there's too much current on them, like power circuits, they'll get warm. So it's not necessarily this inductor. And one of the most common things is people see inductors and think they're faulty. Inductors are almost never, ever faulty. And they almost will never get hot if they're faulty. They just won't work. I've never known an inductor to short because they are effectively a short anyway. They're a coil of wire. They can't really ever get hot because they are faulty. So I have never once in finding problems on a board found an inductor that gets hot because the inductor's the problem. It just isn't a thing. So if you see an inductor, and the way you'd tell is, see how this says AL3? So we'll zoom in a bit on that. You'll see it says AL3. Now, AL is for lux, I believe it is, which is obviously for inductance. So the designators of AL are typically inductors. So this is getting hot is telling us there's a problem somewhere on the circuit that passes through this inductor. So what you'd do in this case is you would remove this inductor. So let's just try, I don't know, with removing this like so. And this is where your bench power is going to come in handy. You can either, if you've got a bench power, this is where it's super useful now to take it off the input, grip it on the mains. So now what I've got is here, I can now inject voltage. So if I inject voltage this side, current this side, well, I am injecting the voltage, but you can see we've got 3 amps on this side of the inductor. If I probe on this side, you can see we've got 100 milliamps. So this side is going up and powers, that'll be powering this transformer, this coil. So there is a little bit of natural current draw, about 100 there. But that's normal. So that isn't a short. This side is a short. So what the bench has allowed us to do is find that the short is this side. And now if we got the thermal, while we inject it onto here, you can see that's the inductor on the bench you're seeing. If I move him out of the way, Oh, that's actually the mat. The mat's still warm, so let's move him up there a minute. And you can see the game, well, it's clear enough that you can see the game gear is here, where my finger is. And obviously the hotspot here is just on the mat. Let me try and just cool the mat off so it doesn't throw us off when we're looking. No, we're still going to get a little hotspot. Yeah, just ignore that hotspot while it cools down on the mat. So what we're going to do is inject power straight onto here. And you can see now, because the inductor isn't on, nothing's getting warm. But what you can see now, see this outline running across and this trace? Your next step is like, oh, there's a short on the board. That is actually the trace. That's where that trace runs. So see how you can see it nice and clearly now? So there isn't necessarily a short, and there won't be a short from that point in the middle here. So where it's hot in the middle, which is basically here, and this is because the trace runs down here, it's not that there's a short here. And the reason you know that is because if you go over where it is, and you kind of go around, you want to go to where it fails. So you go all the way around, all the way up, you go up to the top, and then you zoom in close, and you're failing somewhere, effectively, up here. So this is where it's taken us to, somewhere around here. So you might suspect this capacitor here. We obviously know the short is the other side of a dead short, but if we inject the voltage back in and watch it warm up, you can see this is the trace getting warm. We'll check the other side of the board. Zoom out a bit as well. You don't need to really be close on this at the minute there. There we go. So now we're going to check where we know the short is over here. And we are going to inject, right now actually, we're going to have to move that wire a minute to show you this on the other side, because I can't inject power when it's flipped over. So I'm just going to solder that wire to the pad there. We can now grip this onto there. That's now got the 3 ohm short. There we go. We're free now with the hands to flip over. Remembering this thing has got that bloody 1000 volt flying around. And you can see on this side of the board, no real heat. You can see you don't really see that trace as much this side either. So you don't really suspect this side of the board at all. You're just going to go, ah, there's nothing on this side. Go over to this side where the short is. Nothing. And now we know the short is literally right there. But if we probe over and look where our finger is, like that, and move the finger out of the way, you can see it's stone cold. So this is the problem with dead shorts, and this is very common. You have no way of seeing where that short is, and you will not find it. I've tried every method possible to detect dead shorts, and because they are literally 0 ohm, people think if you short something, it gets hot. That's only true until you get literally 0 ohms. So the lower the resistance, the lower the heat. But all you have to have is 1 or 2 ohms resistance, and you will get heat. So you're not going to see anything really, except the trace getting you somewhere in the vicinity. And you can suspect the short is up here. That's as close as you can now get. The rest is then really by eye. There's no other way of narrowing down that short. That is the biggest problem with actual dead shorts as they are. They're very hard. So they're kind of the worst ones to find. If you wanted to find a dead short, you're pretty much at the point of finding out what trace it's on, by injecting 1 volt typically into certain areas until you find that that area gets warm, finding where the thermal will take you to, and then once you get to as close as you can, we know it's got to be somewhere around here because something's pulling all of the trace of the circuit hot up until this point. So the dead short is located around here, and then you'd really focus your search around this area. That's how you'd basically do. You can do other methods. You can try to get things like really, really accurate DC measurements, which we have on this multimeter. So if I pull up the ohms mode on this multimeter, this is a 6-digit multimeter. So this can detect very low ohms. One idea is, because we've got a short to ground, we can go around with your probe's in resistance mode, probe on, say, a ground point here, probe on the 5 volt over here with no power applied. That's the important step. Put the probe back in and go onto here. And let's probe over the top. So we're going to probe up here. Let's say we suspect the short's over this side of the board. Oh, we've got the coil. Sorry, we'll have to probe down here. So we're going to probe, say, here. And you can see already, this is actually 0.29 ohms. But because my software just rounds it up, this is actually saying 0.29. I might be able to show you that on camera. I can update the software for purposely a high accuracy mode. I haven't bothered writing the software for that yet. But let me see if I can swing this around at all to get you that multimeter. Not quite. All these wires are in the way. Kind of move that. Oh, knocking things off. Right, there is a really, really shit view of the multimeter. But you can see there how it says 43 mega ohms. I don't think we're going to get that accurate enough because this thing is just not really where it wants to be. But if I now go on ground and back onto that pad, you can see there 0.29. You can just about see it with these wires in the way, which, like I say, ignore the ridiculously bad view. I can maybe tweak it out a bit more before it falls off the bench. I'll update the software because obviously I've written this software, so now I can at least write it so you can have a high accuracy mode. But if I go onto there, see 0.29 ohms. So if I go to where I'm probing, I'm basically going on ground and on here. Now the theory is, if I probe closer to where the short is, so I come around and probe, say probe on the point we know the short is. That's the perfect example. Let's probe on the pad here. And then if I look at this camera now, you can see if I probe directly on it, it's going to focus. Of course, this ridiculously shit setup to focus. Come on, focus on that. Is it going to focus? There we go. If I probe directly on the short, you can see we've got 0.1 ohms. So 0.1 ohms is on the actual short. If I move it over to the other side of the board, we're getting 0.3 through the wire. And if I probe on the inductor pad, yeah, 0.3 again. So you can see 0.3 on there. And if I go to the actual location of the short, we're getting 0.1. So if I update my software, that's, you know, the little resistance thing on screen that you're seeing at the minute, if I update that to have a purposeful 6-digit high accuracy mode for short detection, you guys could see it nicely on that overlay there. But at the minute, I've got, obviously, I don't know whether, to be honest, I kind of could. Shall we do it live now? Yeah, let's just do that live. So let me pull up the software. I'm just going to change the software so you can see it on screen and you can see what I'm doing a bit more accurately. But that's another method you can use. For a dead short, you'd need a really accurate multimeter though. So again, expense goes up. It is basically all about the fact that you have to have quite a bit of money to detect the shorts this way. But it clearly does work. So all depending on budget, trying to find the cheapest way of doing it. This method works, but it's obviously a costly way of doing it. Right, so let me just open up my software a minute. And it's not that big of a software. It took me a weekend to write this one, the overlay on screen, so I'm just going to update it now. Where is my code for processing resistance? Turn this thermal off a minute. Resistance. Multimeter, Rigel service. Process resistance value. Right, so what I'm going to do is update the software. If it's less than 1, I'm going to show it as 3 digits of accuracy is fine. So if it's less than, or I'll tell you what, if it's less than 5 ohms, you're talking about probably a dead short. Or do we go 10 ohms? No, 5 ohms. Less than 5 ohms, we will do 0.000. So 3 digits of accuracy here. If I now kill that software, turn that off, compile this, we should be able to now get that high accuracy. This is the benefit of being a software developer as well. I can quickly write the software and change it for what I need and get a new overlay. So in a few seconds, when this spins up, we'll have, hopefully if my code's worked, we'll have a new overlay. Turn on. And go to resistance mode. So now, if I short the probes out, this should go to 3 digits. No. It should be 3 digits of accuracy. Is that not being reported back? Let me breakpoint into here, find out why. Probe. Hits this value. We want to go into here maybe. Right, so it's hit that. Yeah, it should be showing 0, 0, 7. Strange, that should be working. So why is it not working? That is literally... That is correct. That literally is the live value. That's strange. Try once more. Live value. Yeah, 0.083. So that must be getting processed somewhere else. 1 second. Let me step this up in code and find out where. Oh, missed one word in the code. Let me restart that and then we'll be good. Right, turn on. Go to ohms. Dead short. And it kicks in. There we go. Dead short. There we go. Look at that. How easy was that? Right, new software. So now I can show you what I was doing before without the stupid camera being a mile off. The idea is, if you've got a short and you know you've got a short between ground and 5 volts, pick a ground point. It doesn't really matter where, but the location of the ground point will indicate your location to the short. So if we suspect the short's over here, you can touch here. And now if I probe down here by, obviously out the way of the short, you can see we've got 0.3 ohms. And then what I'd do is I'd probe around all the 5 volt positions I know of. We could go on the ASIC. One of these ASICs is actually ground and another one's 5 volts. So I think 5 volts is the bottom. Actually, no, I think 5 volts is about 6 pins down on here somewhere, typically. No, let's go on the cap. Probably easier to go on. A capacitor over here, say. So this would be the 5 volt rail. Oh, I know why we're not getting it. This specific rail is the analog 5 volts. It only goes to the audio port. So you'd have to go to like the... in fact, why are we even doing this position? Why don't we do this? I'm forgetting we can change camera now. We've got it on the overlay. So I'm always going to base me ground over here. So I'll probe the ground on here. And then if I go, say, to this capacitor down here, oh yeah, it's not going to be on the analog. It's got to be this op amp here. So this op amp should be receiving, I think it only receives 2.5 volts, to be honest, the offset. Oh, there you go. So there's 0.26 ohms. So this op amp here is receiving, you probe on it correctly, you know, like 1 ohm, 2 ohm. It's low, but not super low. There you go, 0.4. But if we get right over the short, which is, I believe, this wire here, or effectively this trace here, so this pin, we can probe in even from this side if we suspected. And you see there, the 0.1. So you know the fact that you're close to where this physical pad is here. Now, if I move the ground, leave this one probed here, and go to a ground point over here, say, look how it's changed. So I can use this as almost like a location detector. We get closer, and it starts to get a bit less. We go over to this ground. That's actually more there. That ground is obviously the low one. This ground's low. So once you start getting close to the ground point, you know, using the super low ohm reading, you can try to narrow down that a bit more. But really, that got us no closer than the thermal. So it's a method I rarely use, just because even when you're talking low ohms, even like a bit of dirt on the probes or board can drastically affect that reading. So really, that's the only methods that you can really use is the resistance, the IPA, the thermal, the bench, and I guess the low resistance is the extra mode. You've got a dead short, which is literally a bridge. You've got a low ohm short, which is typically component failure, or say this IC fails internally, this IC might just heat up because inside it's pulling too much current to handle and it dissipates the heat. So again, thermal would pick that up easy. None of the others would really point you to this location. IPA in this case would probably work. This would bubble because it'd get hot and the die in the center is what's getting hot. So you detect this with IPA. But 99% of the problems are always thermal is your best way of going to detect a short. Removing components, yeah, that's the good option to, if you suspect components and they're dead, like say capacitors, they're semi-common to fail and short. You'd look at the schematic, find out where this rail is going, so we know it's the analog rail, and you could remove components that are on that rail until the short went away. That's a good method to find it. It's just a bit more long-winded. If you don't have a dead short, though, thermals will almost always point you in the right direction. Just be mindful of things like the inductor getting hot. So I'll show you another example of another potential thing to look out for. That's like a problem that you should really be aware of. And that is, if I bridge this back, so I'm going to bypass the inductor, we don't really care for now. Just put a giant bridge on. We've now got the short back on the board. Let's show you another thing, and this is where power supplies can fail. They'll either die and stop working, which this now probably will for the clean juice, or we will see the other potential problem with what you might think on thermals as a problem that isn't. So if I now connect the clean juice back up to this board, I won't turn it on yet. I'm going to turn the thermal camera back on, and then I will re-show the it's in this position here, maybe. Yeah, the thermal's on this view only at the minute. So if I turn the thermal back on, I might have to toggle deactivate and activate maybe. Why is that thermal not showing? Oh, I've hidden it. There we go. So now we've got the thermal back on. If I turn the power supply on, so I'm now pointing this at the power supply. There's my hand. If I turn on, look at that. So the clean juice is getting super hot. And again, this would point down to this 5-volt regulator here. So these caps and this, specifically this transistor that the power is passing through, is getting very hot. So you can see there, if I turn on, these are getting to hundreds of degrees. And that's because the power is passing through this transistor, so that's getting hot. This is the regulator that generates the 5 volts, so that's getting hot. So again, when you look for thermal, you have to bear in mind that it's not always just where the heat is. You have to think, right, the heat is coming off this board from the 5-volt rail. So you want to disconnect the 5-volt, send the power through bench, so the bench won't get hot. So then you know you're not dealing with the power supply. And then you can track down. So you have to be aware of that as well. And there's only one other thing to bear in mind with thermals, and that's really everything about the red herrings of detection things. If I look around this board and try to find what's hot, you can see for one, let's see if I can find something. Probably this board isn't the best, maybe this one. So get a Dreamcast Clean Power. Now I look around this board, has that got anything on? Not so much now. This one. Trying to find a board with a good example of it. Not so much. Clean screen. So clean screen in a way. See them dots there? So the dots on the thermal are showing us if there's heat. So see them dots? They are basically these pads here. And what this is reflection. So anything that's metallic and reflecty, you can see if I twist the board, the dots move around. And obviously, this is not a super accurate thermal camera, but you can see the point of if you have anything reflective or metallic, it reflects radiated heat as well. So it looks like it's, places are hot when they're not. So if you've got something with, say, like a power core here, and this metal cage and the USB and the springs, they normally reflect the light and the heat. So if you get them in the right angle, see how I'm tilting it? And the light, that's the studio light above, and that's the heat from the studio light reflecting. And the fact that it comes and goes when I twist the board is a sign that it's reflected. So this is something you just have to bear in mind with thermals, is those springs look like they're hot, and they're not at all hot. That's just literally the fact that they're metallic and reflective. It's reflecting light, which is then radiated as IR, and you'll see it on the thermal camera. So that's just something to bear in mind. Watch out for reflected, basically. So I don't think there's much more to cover in terms of detecting shorts. The only thing is, inductors are the thing to look out for. If they get hot, it's not going to be the inductor, it's going to be something else. So remove your inductor and inject 1 volt either side, or even 0.5 volts is your safe bet, because like GPUs and things can actually run at 0.5 volts. So injecting like half a volt is safe on pretty much everything anywhere to find a short. And follow with a thermal if you can. I'd recommend thermals if you're going to try and find shorts. It's the biggest method to detect most of the problems. We have, if not, we said obviously resistance mode is good and cheaper, but low ohms resistance mode is expensive to be able to, like say, measure the resistance in skin. Would be 3 million ohm resistance over my skin. But to get low accuracy, you really need an expensive multimeter. IPA I've rarely found useful. Like IPA, you spray over and you're looking around and it dissolves in air anyway, and by the time you find a spot you suspect, I don't think IPA is really worth doing. Just invest in a thermal camera. And then bench power gives you the power draws on screen, which is a good indicator. Really, the bench is used for injecting power to be able to isolate the positions and measuring how much power is being drawn to even know you have a short in the first place. So it's kind of a combination, I'd say, of a bench power and thermal is what I always use to detect shorts. So that's really it for what we need to cover. These they can go back. The early morning streams we'll see on time, because when we do the sub-only streams, I find that these early morning ones rarely get any interaction, and everybody else that comes on at night misses them. So we might look at relocating these times based on like how it goes, basically, with the views, and move them to a different time. A lot of people want to see me do it at like evenings, which is not really ideal for me, because obviously I want my evenings. I already get up early and work early. So I suppose it's like we'll see how these go in terms of the early morning streams, if we pick up on the subs. And, because some people, mostly in America, will pick up on these early morning ones, but places like Australia definitely won't, and other parts of the world, they tend to find the 4:30 in the afternoon in the UK seems to be the more popular streaming time. So we'll just have to, obviously, see if we want to move this early morning stream, because we don't want to be covering things that people want to see and then missing out on the interactive side, because they'll have questions. That's kind of the point of the live streams, to be able to have the interaction, basically. So that's it for this one, unless anyone's got any questions. If you missed this, obviously you won't know if you missed it from saying on here, but this is going to be a permanent VOD on YouTube, so you can always look back and watch this on the VOD. You can leave a comment as well on the VOD and it should pop up for me. regarding these times. Like if you think it's better to move these early morning ones to afternoon, maybe just do 2 in the afternoon and have the fixed time, we can. But otherwise, I'll keep doing the early morning ones. I like the early morning ones anyway, but in terms of sub-only early mornings, they're almost non-existent for interaction. Whereas you compare that to the 4:30, and I literally can't keep up with the comments, if you know what I mean. So it's like a polar opposite. You have like me sitting talking to myself at 6:30 in the morning versus I literally have people saying I'm not monitoring comments because we get so many. So it's a balance between the two. Yeah, afternoon for some, 2 a.m. That's the problem. We have viewers from pretty much all over. So it's very hard to find times that work for everybody. I think the hardest time is for Australians because short of me doing it at 7 p.m. over here, which is then what, something like 8 in the morning in Australia? Not sure, 8, 9 o'clock. Any other times, and it's just not really a time they can join. Model of microscope. It's an AM scope. So AM scope. Put this back here a minute. Turn that off. Turn that off. There we go. Yeah, so AM scope, and I don't know the exact model because I brought so many. I could probably find a link for you now. Let me just open AliExpress and see if I can find a link. Yeah, so it's like getting late at night for you as well. Yeah, I think if I do normal public streams, the 6:30 in the morning are the most active, but the sub-onlys aren't, if you know what I mean. It's like, it's weird. So I might do the public ones early and the sub-only streams later, we'll see. But 4:30 is, like I say, way more active. And that's what we really want as many people to benefit from it as possible. Right, this looks like my model. It just looks like it's a black colour instead. So if I pull that up, you can see that looks like mine. Very similar. So if I go to this view, say, pull this over, zoom out and up, I'd say that's the model I'm using. Looks very similar, don't you think? I think they just changed the colour. So I'd say that your safe bet is that's the one I'm using. Obviously, they're not really branded and they haven't got part numbers as such. They're just what they are, but that definitely looks like mine. Even the eyepieces. Well, the eyepieces, I've got loads of them, so I changed them. So I wouldn't worry about the eyepieces. They're all the times 20, WF 10 times 20 normally. So that's the one I'd potentially go for. But if not, just type AM scope and you'll find most of them are good. Just try to go for this eye style because, like I say, some of them where they don't have these secondary pieces of eyes, to me, when I look through them, very difficult to see through. Like, I literally can't use them. I've got one. Yeah, it's literally just dumped up the top. You probably can't see it, but it's just dumped up here, behind here. That's what I can't even use. And see how the eyepieces are just straight into the head. Those, to me, I cannot see. Like, no matter what I do, I can't see them, basically. Something to do with the vision. Maybe my interpupillary distance, as it's called, is different for them, but I'd personally stick with the other ones. Yeah, and I do also need to do it when it suits me. Yeah, that's kind of why I don't want to do the evening streams, just because, like I say, I'm up early anyway. I stream a lot, I do videos a lot and work a lot. By the time it comes to the evening, I want to settle down. You know, sometimes I'll want to work in the evening if I haven't worked much in the day. But I wouldn't really want to commit where I have to do, you know, a paid subs-only stream that I want to commit to for the people that are obviously supporting the channel. I wouldn't want to be feeling like I didn't want to be on the stream. And I think the evenings for me that'd be where I kind of feel like I don't want to be on sometimes, because that'll all depend on how I feel. But hopefully this one was useful for you guys. We need to jump on Discord, so obviously all the members, if you link your YouTube or Twitch to Discord, Retro6 Discord, you'll be invited to Elite members. In there, we need to now plan the next videos. We have no schedule. So obviously I'll be on next Tuesday and next Wednesday. Like, the schedule seems pretty solid, but we need to plan in what's next. We did say potentially using the oscilloscope, maybe showing more of those trace repair. Maybe we do some trace repair stuff. But yeah, let's work out the schedule for the next sort of 4 videos on the Discord. So that's it, guys. I will catch you next Tuesday for the sub only, and I'll probably be streaming today and tomorrow, and then I'll be doing software probably Friday, Saturday, Sunday. So I will catch you then. Thanks all for joining in.